October 1965. The American military is about to detonate massive underground nuclear bombs right through the bedrock of Amchitka Island in Alaska. In a frantic panic, wildlife biologists wrestle 413 thrashing and biting sea otters into heavy wooden shipping crates, load them onto cargo planes, and physically hurl them into the freezing dark waters of Alexander Archipelago. They dropped them into an absolute underwater graveyard. The coastline was a barren wasteland completely stripped of the giant kelp forests that used to dominate the ocean floor. That chaotic military airlift was not just a desperate rescue mission, it accidentally triggered the most aggressive, large-scale ocean terraforming project in recorded history. To understand how a panicked airdrop rebuilt an entire coastline, you first have to look at the invisible catastrophe that destroyed it in the first place. For nearly 200 years, people looked at the coastal waters of southeast Alaska and saw a flat, rocky bottom. Fishermen dragged heavy nets over the reef. Locals stared into the clear, freezing water, saw a barren landscape, and assumed that was natural. They thought the ocean floor was supposed to look like a submerged parking lot. This was a massive case of collective amnesia. Scientists call it a shifting baseline. It happens when a wound is so incredibly old that everyone forgets what the healthy body looked like in the first place. The reality was a horror story of unregulated greed. In the 18th and 19th centuries, Russian and American fur traders arrived in the Pacific Northwest. Sea otters possessed the densest fur on the planet, boasting up to 1 million hairs per square inch. Traders wanted those pelts for overseas markets. Hunters slaughtered the animals by the tens of thousands, wiping out the sea otter population along the southeast Alaskan coast by the early 20th century. That slaughter triggered an invisible chain reaction. Without otters swimming in the water, sea urchin populations exploded. Sea urchins are spiky, slow-moving eating machines. Millions marched across the ocean floor. Their favorite food is giant kelp. Facing no predators, the urchins bred into the billions and chewed through the base of every kelp stalk they could find. Losing the kelp meant losing the foundation of the coastal food web. A healthy kelp forest is a towering, three-dimensional jungle, growing up to 100 feet tall from the seafloor to the surface. The thick canopy serves as a critical nursery for young rockfish, salmon, and herring. It offers a protective sanctuary for harbor seals and migrating whales, while acting as a massive physical shock absorber that dampens the brutal energy of fierce winter storms before those destructive waves can hit the shoreline. The hungry urchins erased this world. The vibrant, multi-layered jungle became a flat dead zone. Marine biologists call this desolate state an Urchin Barren. This barren state became the new normal. For generations, the ocean was stuck. The system could not heal itself because sea urchins are incredibly resilient organisms capable of living for decades. When food runs out, these invertebrates do not starve. They enter a dormant state, sitting on the bare rocks to wait. If a single new blade of green kelp tries to grow, the dormant urchins wake up and devour it instantly. The ecosystem was broken. The fish nursery vanished. The ocean lost its natural architecture. Humans simply forgot the underwater forests ever existed, accepting the dead zone as a permanent fixture of nature. Then the military transport planes arrived from Amchitka Island and dropped 413 confused, angry otters into the water. What happened next defied every model. John Vanya worked for the Alaska Department of Fish and Game. He orchestrated those frantic translocations in the late 1960s. Vanya packed biting sea otters into wet wooden crates, hoping to save a fraction of the population from underground nuclear tests. He had no idea he was deploying a biological weapon that would terraform the entire southeastern coastline of Alaska. For a long time, nobody tracked the results of that chaotic airlift. The otters were left alone in the freezing dark waters of the Alexander Archipelago. Then, in the early 1970s, a young marine ecologist named Dr. James Estes arrived in the Aleutian chain. Deeply curious, he wanted to figure out what these relocated animals were doing to the underwater environment. Estes started rigorously comparing the islands that had strong sea otter populations to the islands that were empty. What he discovered was not some mystical harmony of nature. It was brutal, mechanical efficiency. The sea otter operates like a biological buzzsaw. Most marine mammals survive the freezing Pacific Ocean by building up a massive layer of thick blubber. Think of seals, walruses, or whales. Sea otters lack this fat. They rely entirely on their dense fur to protect them from the lethal cold. Without that insulating layer, their internal metabolism has to run at maximum capacity at all times. The animals must burn calories at a furious rate just to keep their core body temperature high enough to survive. To fuel that raging internal furnace, a sea otter must eat roughly 25% of its entire body weight every single day. To put that in perspective, if a human being ate like a sea otter, that person would consume over 40 pounds of solid food every 24 hours. They are relentless eating machines. And the ultimate fuel source for the sea otter is the sea urchin. The mechanism of ecosystem recovery is beautifully violent. An otter dives to the rocky ocean floor, locates a spiky urchin, and grabs a heavy flat rock. Swimming back to the surface, the predator rolls onto its back and places the rock on its chest like a crude anvil. Gripping the urchin with both front paws, the otter repeatedly smashes the shell against the rock until it cracks open. After scooping out the soft insides, the animal immediately dives right back down to hunt for another one. A single sea otter can easily smash and eat dozens of large urchins in a day. A raft of sea otters can systematically clear an entire rocky reef of urchin swarms in a matter of weeks. The otters do not plant the giant kelp, fertilize the ocean floor, or carefully manage the reef. They just kill the exact pest that prevents the forest from growing. Once the urchins are removed from the equation, the giant kelp can finally take root on the rocks. Giant kelp is one of the fastest growing organisms on the planet. Under the right conditions, a single stalk can grow up to 2 feet in 24 hours. As the otters ruthlessly cleared out the Urchin Barrens, the kelp exploded toward the surface. The towering three-dimensional underwater jungle returned to life. The protective canopy for the juvenile fish came back. The natural shock absorber for the violent winter waves was rebuilt. The entire structural architecture of the coastline was radically restored by one single predator. John Vanya and his team originally relocated 413 otters. And then the math changed. You might listen to this story and think it sounds like an exaggerated environmental fairy tale. It is easy to assume that a few hundred animals could only affect a couple of small, isolated bays. You might wonder if the impact of a single predator is being overblown for the sake of a good narrative. But the hard clinical data proves the exact opposite. The recovery was so aggressive and expansive that it forced marine biologists to rewrite their coastal textbooks. In 1974, Dr. James Estes published a landmark paper in the peer-reviewed journal Science. Backing up his visual field observations with rigorous statistical data, he proved that the sea otter was not just another random animal floating in the coastal food web. It was the biological engine that held the entire structural system together. Biologists call this a keystone species. The concept is named after the wedge-shaped stone located at the very top of a traditional architectural arch. Remove the keystone, and the heavy stone structure collapses into rubble. Put the keystone back, and the structure can hold massive amounts of weight. Dr. Estes proved that the sea otter was the critical foundation of the Pacific coast. The physical results in Southeast Alaska were staggering. The original population of relocated otters arrived in a coastline packed with an unlimited food supply of dormant sea urchins. Confronted with an all-you-can-eat buffet, the otters gorged themselves, bred rapidly, and relentlessly expanded their territory. Over the next few decades, those 413 otters multiplied into a massive, hungry population of over 25,000 animals. They did not just fix a few local coves. The predators systematically chewed their way down more than 1,000 miles of rugged Alaskan coastline. As the otters steadily expanded their hunting territory, the giant kelp forests followed right behind them. Satellite imagery and rigorous underwater marine surveys from the Alaska Department of Fish and Game documented a total landscape transformation. The dead flat Urchin Barrens were violently replaced by millions of acres of towering, thick kelp. This massive resurgence of underwater plant life triggered a secondary biological explosion. The dense kelp canopy provided a critical, safe haven for vulnerable fish fry. Populations of rockfish, Pacific cod, and Pacific herring skyrocketed. The water teemed with wildlife again, drawing larger predators back to the area to hunt the abundant fish. Harbor seals, sea lions, and bald eagles flocked to the restored coastline in massive numbers. Then climate scientists looked at the new numbers and realized something even bigger was happening. Giant kelp does not just provide physical shelter, it is a highly efficient carbon sink. As those underwater forests grew up to 2 feet a day, they pulled enormous amounts of carbon dioxide straight out of the ocean water. Modern clinical estimates suggest that the vast kelp forests restored by the sea otters can sequester up to 8.7 million tons of carbon, locking it away deep underwater. This was a total ecosystem revival driven entirely by one furry urchin smashing machine. The original desperate translocations from Amchitka Island became widely recognized as the single most successful marine conservation project in recorded history. The coastline was healed, the ancient natural balance was fully restored. But the massive success of the sea otter created a terrifying new reality. When you read about the triumphant return of the giant kelp, it sounds like a perfect victory for nature. The ecosystem healed itself. But nature does not care about human economies. The otters did exactly what they were supposed to do, eating everything in their path. That ravenous appetite created a massive, immovable wall of conflict. The core problem is very simple. Sea otters do not just eat sea urchins. They target whatever is easy to grab and packed with dense calories. Once the Urchin Barrens were cleared out, those 25,000 otters needed to find a new food source to fuel their furious, high-speed metabolisms. The population immediately pivoted its hunting strategies. Swarms of otters started diving for Dungeness crab, digging up massive geoduck clams, and gathering sea cucumbers and mussels. Those are the exact same species that keep the local human economy alive. Southeast Alaska relies heavily on commercial fishing and commercial diving. Families have spent generations building small businesses around harvesting Dungeness crab. Divers risked their lives in freezing water to pull geoduck clams from the ocean floor. Suddenly, these human workers found themselves competing against hungry apex predators, and the humans were losing badly. Because a sea otter requires 25% of its body weight in food every day, the animals hunt relentlessly. The otters were faster in the water, could dive deeper without heavy equipment, and never took a single day off. Commercial fishermen watched in horror as the predators systematically stripped their traditional, highly profitable harvesting grounds bare. Millions of dollars in local revenue simply vanished into thin air. Small, multi-generational fishing operations were pushed to the brink of bankruptcy. A bay that used to support 3 commercial crab boats suddenly could not even support one. The impact hit indigenous communities even harder. Alaska Native tribes have relied on coastal subsistence gathering for thousands of years. Digging for clams and harvesting crabs from rocky beaches is not just a casual economic activity. It is a critical foundation of their food security and a deeply ingrained cultural survival mechanism. When the otters moved into a new coastal inlet, the local beaches were violently wiped clean within months. A reliable, ancient food source that had sustained human communities for countless generations vanished, and the humans living on the coast were legally powerless to stop the destruction. In 1972, the United States federal government passed the Marine Mammal Protection Act. This is an incredibly strict, unforgiving piece of legislation, making it a serious federal crime to harass, hunt, capture, or kill a marine mammal. The sea otter was fully protected under this heavy legal shield. If a commercial fisherman saw a raft of hungry otters destroying his crab pots and eating his livelihood, he could not do a thing to stop them. Even firing a harmless warning shot into the air could result in massive federal fines or serious prison time. Conservationists and marine biologists celebrated the incredible return of the kelp forests, but the locals living on the harsh Alaskan coast felt sacrificed for a scientific experiment. The government had dropped an untouchable, legally protected predator right into their backyards. The ultimate environmental success story had violently mutated into a devastating economic crisis for the people who actually lived there. The story of the Alaska sea otter relocation forces us to ask a very uncomfortable, deeply philosophical question. What does a fully healed ecosystem actually look like? For over a century, human beings operated under the collective delusion that the dead, barren ocean floor was normal. We built an entire regional economy and a modern, comfortable way of life around a profoundly broken biological system. When we finally fixed the system and put the Keystone predator back in its rightful place, the ocean returned to its ancient, deeply wild state. The kelp forests towered again, the water teemed with wildlife. But we quickly discovered that modern industrialized humans no longer fit neatly inside that wild picture. We all want the towering kelp forests. We want the massive carbon sequestration to fight global climate change. We want the thick schools of herring and the majestic returning whales. But we also want the lucrative commercial crabs and the abundant subsistence clams. We want a fiercely wild ocean, but we desperately want it to behave like a carefully managed agricultural farm. The sea otter proves with brutal biological honesty that you cannot have both. When you unleash a true apex predator back into the wild, you do not get to dictate the terms of the ecological recovery. You cannot negotiate with a sea otter. You just step back and watch the merciless biological engine run. The otters are still out there right now. They are still diving, breeding, and relentlessly expanding their territory along the Pacific coast. The bitter conflict between the returning wild and the modern human world is far from over. It is only going to get louder as the ecosystem continues to rewrite its own rules. If you thought the ocean terraforming power of a hungry sea otter was insane, wait until you see what our next subject did to an entire river system. A few dozen rodents were dropped into a barren wasteland, and they accidentally engineered a drought-proof fortress that baffled federal hydrologists. You will never look at nature the same way again.